Great Dane Trailers, Tennessee is a Memphis plant which manufactures truck trailers, including over-the-road platform trailers, curtain-side trailers, and converter dollies. The number of employees varies with production requirements. During 1989 and 1990, the high was 336 and the low was 163. We presently employ 191 workers. The project that won the 1990 Tennessee Governor's Award for Excellence in Hazardous Waste Management was the elimination or significant reduction of both solvent vapor emissions to the air and paint-related requihazardous waste. Great Dane trailers are assembled from steel parts fabricated in the plant and miscellaneous parts purchased outside the plant, such as wheels, springs, axles, and tires. The parts include a wide assortment of steel structural shapes, form shapes, sheet, plate, pipes and tubing, etc. The parts are assembled primarily by the welding process. Some fasteners are used. The purchase items include air brake accumulators and shoes, drums, clearance lamps, tires, suspension posts and springs, heavy cast iron wheel hubs, pre-painted wheels, and wood and aluminum flooring. The final product is painted and undercoated for appearance and product durability. In the past, when the trailer reached the end of the assembly line, it was prepared for painting. Items such as wheels, tires, and air and electrical connectors were covered with plastic or masked off. The trailer was then moved into a large paint booth where it was washed down with 1,1,1 trichloroethane prior to painting. The washdown cleans and degreases the steel surfaces of the trailer. The actual painting process may involve as many as 4 coatings in various colors. The different types of coatings usually applied are a primer, enamel or polyurethane top coat, color matching rust preventative visible undercoating, and a black, not normally visible undercoat. Following painting, the trailer is allowed to dry in ambient air. Finishing procedures include installation of serial plates, name plates, mud flaps, and lights. Then the trailer is moved to the storage yard for pickup or delivery to the customer. As a result of the use of 1,1,1 trichloroethane as a thinner in the paints and as a cleaning, degreasing agent, an average of 224,000 pounds of 1,1,1 trichloroethane vapor was emitted annually into the atmosphere. The following amounts, as reported to the EPA in the annual Toxic Release Inventory, R reports, were released to the atmosphere during the 1987 to 90 period. As the chart shows, in 1987, we emitted 129,000 pounds. In 1988, 325,000 pounds. 1989, 290,000 pounds. And in 1990, 152,000 pounds. This totals to 896,000 pounds for an annual average of 224,000 pounds. In 1988, because of an EPA requirement, 1,1,1 trichloroethane was substituted for xylene and other paint solvents. The 1990 figures reflect reductions as a result of changes made in the fourth quarter of that year. As far as hazardous waste is concerned, the only requihazardous waste stream generated was waste paint-related materials. These materials are generated when a solvent is used to flush the paint lines for color change requirements or for cleaning the paint lines. Additionally, leftover unsuitable paint which must be disposed of is combined with the waste solvent. Because the paint and solvents contain xylene, toluene, and 1,1,1 trichloroethane, the waste was handled using EPA waste codes of F002, F003, and F005. An average of more than 123,000 pounds of waste paint-related material was generated and shipped off-site for treatment or disposal as hazardous waste during the period of 1987 and 1990. The following amounts were reported to the Division of Solid Waste Management in Hazardous Waste Stream Reports. In 1987, 101,640 pounds, 88, 180,849 pounds, 1989, 130,880 pounds, and in 1990, 79,640 pounds, for a total of 493,009 pounds, averaging 123,252 pounds. It is estimated that in 1991, 2,640 pounds will be generated, resulting in an annual reduction of 120,612 pounds, or 98%. In 1990, 40,400 pounds of hazardous waste were shipped off-site for treatment, and 36,000 pounds were treated on-site by using gravimetric separation or distillation procedures. The material treated on-site was recycled for use as flush solvents and undercoating. Because of publication of the EPA Toxic Release Inventory reports, the upcoming passage of the Clean Air Act, and the high cost and impending elimination of 1,1-trichloroethane, an in-house study was conducted to determine how we could reduce and eventually eliminate its use. The study revealed it was being used to lower the viscosity of primers and paints, and also to clean and degrease trailers to ensure good paint adhesion. As a result of the study, and after testing various methods of lowering paint viscosity and using different cleaning chemicals, the following changes were made. The paint system was modified by adding high-temperature paint heaters to raise liquid temperatures, thus lowering paint viscosity. Recirculating paint lines were also installed to allow paint to recirculate through the heaters when not being sprayed, thus maintaining its temperature. These changes resulted in significant reductions in the amount of 1,1-trichloroethane previously used as a thinner. The capital outlay of the project was $20,815. Cleaning and degreasing of the trailers was moved from the paint booth to other stations on the production line. This change allowed a biodegradable, water-soluble degreaser time to dry prior to painting, thus eliminating 1,1-trichloroethane as a cleaning degreasing agent. The capital outlay of this project was $0. The idea of recycling and reusing the hazardous waste generated from paint operations originated in a waste reduction assessment report compiled by the University of Tennessee Center for Industrial Services. Tests of bottoms resulting from galvanometric separation were conducted by Lilly Industrial Coatings Incorporated. It was determined that by adding oils, hardeners, and black pigment, the bottoms could be made into a superior undercoat. This undercoat proved itself by surviving a 500-hour accelerating corrosion test. As a result of the Lilly findings, we purchased a 60-gallon distillation unit. Virtually 100% of the paint-related material previously shipped off-site as a hazardous waste is now recovered and divided into reusable flush solvents and recyclable paint sludge still bottoms. In addition to the distillation unit, a 5-horsepower blender was installed to mix the still bottoms with the special oil blend purchased from Lilly. The cost of the Lilly additive, when combined with the recycled still bottoms, is about the same as the previously purchased undercoat, about $3 per gallon. Because waste paint material is being recycled, Great Dane no longer generates hazardous waste for off-site treatment or disposal. The capital outlay for the waste recycling program was $23,572. Economic benefits of the waste recycling program will be considerable. The elimination of 202,000 pounds per year of 1,1-trichloroethane represents an overall savings by Great Dane and its paint suppliers of $82,820 per year. Great Dane's savings will be about $73,440 per year. The savings figures are based on the 1990 market price of 1,1-trichloroethane, which was 41 cents per pound. Based on 1989 data, the recycling program will save about $120 per day in disposal costs, $30,000 annually, about $80 per day in solvent purchases cost, $20,000 annually, and about $12,000 in undercoat purchases annually. This is a total of approximately $62,000 per year. Since the cost of managing, transporting, treating, or disposing of waste continues to escalate, the savings should increase in the future. The total economic savings expected for 1991 is $135,440 on an investment of $44,387. This is a return on investment of 184.7% with an expected payback of less than 4 months. Significant environmental benefits have been realized as well. During the period 1987 through 90, Great Dane emitted into the atmosphere a total of about 896,000 pounds of 111 trichloroethane. This represents an annual average of about 224,000 pounds. Because of changes made to paint equipment and in trailer cleaning and degreasing procedures, the emissions will be reduced by 202,000 pounds per year. Had the changes been implemented in 1987, only about 88,000 pounds would have been emitted rather than a total of 896,000 pounds. The environmental benefits are obvious. The recycling of hazardous waste into reusable flush solvents and into a usable undercoating product almost eliminates the need to transport and treat or dispose of hazardous waste off-site. Not only does it reduce the unnecessary waste of usable product, it significantly lowers the potential for hazardous waste accidents and spills, which could occur during the handling and transporting of the waste. We at Great Dane feel great about what we have accomplished, and we are pleased to be sharing the success of this project with other metalworking and transportation industries. Thank you.